So it is all about generators. What is a generator? If you remember, in the last class, I told that there are different data types. The basic data types are like non-iterables, like int, float, none, etc. These are very basic data types. There is nothing to optimize there. But when you go for mutable, sir, means iterable objects, it can be mutable or immutable. They will hold more than one value, right? These are data structures which will store some other things. If we have a list of numbers like that, means there is no practical limit on what is the maximum that we can store. So due to that, like it can store any large data, so it can lead to crashing. To avoid that kind of scenario, for a better optimized usage, we have the iterators. For iterable objects, we have iterators. But for user-defined functions, we have generators. So generator means what? It is for the user-defined functions I told. So primarily, the concept of generator and iterator are the same. Means if you have some sequence or some values, what is happening in the generator also? Instead of generating all the values, it will store the state that yes, I need to give these many values, and it will give. Let's take the example of a range. Range is not a pure iterator, but still I am taking this because if I say like here, give the values from 0 through 1 million with a step of 2, means will it give all the values? No. It will store the state that yes, I need to give the values from 0 to 1 million with a step of 2. The moment you ask, it will give the first 0th value. Then the state will be replaced that yes, I need to give the values from 2 to 1 million. So means like that every time the state is changing. So it's easy to store the state than storing all the values. So that kind of things happens. So what I'm trying to say, if you till now you have seen iter protocol. Iter protocol works on the built-in functions. Sorry, built-in data types. So there is nothing that you do. You just pass to that iter built-in function. It becomes an iterator. That's what. Whereas here the scenario is slightly different. If I take any function just like that, it will not become a generator. Means, let's say, if I take a function, if I generally you define any function like this, and after that you make a call. If I just define that it is my generator, it doesn't mean that it should be a generator. It is an ordinary function which was executed. Then, sir, when it will become a generator? So assume that if you don't return also, the default return is done. We know that. But instead of a return, if you place a generator, so means like instead of a return, I write yield of say none or whatsoever you do. I did a yield. The moment I did a yield, did you see what happened? Means same like your ordinary function, but instead of a return, you replaced with a yield. Then the magic started. Okay, sir, how this actually works? So means you need to understand what is the difference between yield versus return. So this is the common question that everyone gets to know. Let me take this example. Say like my ordinary function. Define my function. In a my function, pictorially to say, I am saying that I am in the function and I say like return 111. So return 222 and return 333. So if I assume that I have like this, now if I make a call to this function like my function, what will happen? So it will stop there itself. It will not go further. Means if I can write like, say, so printing, so 111. Did you see that the code was not reached? So means what? We know that return is the last executing statement in any function. Means there can be more than one return. Maybe sometimes there can be based upon a key situation like a if condition, etc. But the moment it encounters a return, the execution stops there. Whereas if you go for the yield, instead of a return, I will replace with a yield. As I told, it's a thing. I will tell instead of like a function, I call it as a generator. So here also I call it as a generator. So name I can write anything, but like if you have this kind of scenario, only then it will be called as a yield. See, now if I execute, what is saying? In the previous case also you saw, even if you have a single line execution also, it will be like this. So what is the difference in terms of function call? So ordinary function will execute with function call. That's what we know till now. But generators will not execute until you ask for the first value. Means, what is this concept, sir? So let me take it again for you to help. So I am assigning this value to something, say result, gen result. Okay, generator result I am assigning. I am asking, hey, so print the type of this generator result and this generator result. Did you see it is saying I am of type generator and it's of generator object. Then how to get the values from it? For the generator object, can I ask for like call like this? It will throw an error because it's not callable. But if you want values out of it, hope you remember what I told in the iterators concept. If you want to get the values, either for loop on it or do something. So means for value in, so generator result, I can ask to print value is equal to. Now did you see what happened? Every time the value is coming, did you see 3 values came? It's something interesting, right? So, and again, we can also convert to list, I told. If I convert to list, I don't get, because it is disposable object. Disposable, right? Means only once we can get. If you want again, we need to reassign and we need to get it. If I reassign and I ask to convert, I say like list of generator, what is that? Generator result. Did you see? In the process, did you understand one thing? So for you to better understand, I am writing all these things together in one place. So you generated the result and I am asking the values. And did you see in the process, it is saying printing 111. Maybe like I can ask like printing 222. Instead of printing, I am doing like a yield, right? Say yielding, I write. So I'll like yielding 111, yielding 222, like that I write. You see? So if I execute right now, did you understand? So whenever it is going to that situation, it is printing the statements. And also you got all the values to it. What are these values? Each time you are yielding, those values you are getting. Okay, I told that in iterators also, when you are retrieving the values, either you can do a for loop or you can convert to another data type. But if you want one value at a time, we should go for next built-in function I told. Hope you remember. Next built-in function if you want to get one value at a time. Now let me do that, then you will understand more clearly. If I go here, I create a generator object. This is fine. Now if you want one value at a time, I can go for next built-in function. Now you will understand the full story of this thing. I should give this generator result. Means, you see, till now for ordinary functions, the moment you made a call, it will execute. But for generators, after making call also, it will not execute. The moment you start asking for the first value, the execution starts. And did you see what happened? The moment you asked, it executed till the first yield and it paused. Means like state suspension mechanism, we should call it as. This is called as state suspension mechanism. What is this concept of state suspension, sir? So that's what we need to be very understanding. State suspension means after executing till the first yield, it will pause. Generally, any function, when you execute, what will happen? It will execute from the starting till the end. Again, if you call, it will execute from the starting till end. But it will pause there, and next time when you do a next of gen value, you see earlier it passed at a yield 11, right? It gave the value. Then it will resume till the next yield. Now it will print this yielding 222 and it will result. You see, observe. You see what happened? It is yielding from the next step and it is giving you the answer. And similarly, if you go for the again and next of this gen result, you can notice that it is giving one more step. Means it executed this. And now the execution is at it. State suspension done. And again, if you ask, there is one more, right? So it will do next of gen result, it is has. So finally you have a yield, and after that you don't have value. Then right? So when you go for individual next, what will happen? It will throw an exception. That stop iteration exception. So with this concluded, I told you with a while loop also we can get the values. So how to get also I told. So with while loop, how to get? If I have a generator, what I do? While true, while true. Every time in a try exception I need to handle. So every time I need to do a print next. So means like I do a next of what is that? First I need to create make a call, right? So generator result is equal to, first make a call to that function. That result, whatever is there, that for that I need to ask next. So I need to do like except stop iteration exception. Stop iteration exception will not give any value. It's just a stop iteration. So then like in that case, you can break it. So till that case, you can execute and get the values. Now you see in this case, what happens? Every time in the process, it is getting the values. But as you are not storing the result anywhere, you're not getting. But if you get the value and store somewhere, maybe like, so values is equal to some list, and you are doing like value dot append of values dot append of value. And if you print the values, you see, so whatever the values is, I think I need to do in a string. You see, you dot the process and also this thing. But there is one thing that you need to be aware. Sir, can we have a combination of both yield and so return together in a single function? So generally, Pipette says that please don't use a combination of so yield and a return in a single function, because it can create some kind of confusion that what has happened, right? To avoid that, they say don't use a combination of yield and this thing. But given said that, what will happen if you use it? So in some cases we can use if you are aware. So means like the same function I am writing, but in the last I wrote no more value to yield, right? So till now we know that a stop iteration, whenever if you ask also, if I say as example result, and if I ask to print, hey, print the ex. So did you see that nothing was printed? So stop iteration will get nothing, no value. But the same example if I take and if I ask, there will be a slight difference in the output. Generally, it will execute one iteration at a time, one state at a time, it will execute. But in the values written in the last, did you see? Whenever there were no more yields, and finally if we have a return, means if you don't return also, by default none will be returned. That's the reason nothing will come. But in the stop iteration exception, if you want the message to be displayed, then you write the return. So I wrote like no more values to yield. Did you see the message is the same? No more values to return. If you want, you can make it like a RPR of EX. You can notice that. Stop iteration exception of no more values to yield. So if someone asks, should I have yield and return together? It's not a good practice. But in which case we need to have, I told you. like this. Now let me go with one more example. So by this you understood what is a generator object. So now I want to clarify about the generator objects. So till now, based upon our learning, we understood that okay, generators are designed for like user-defined functions. They are disposable. They cannot be indexed. So same like the other iterators. So iterators and stores the state as I told you first. And whenever you are going for large computation handling, it is suitable. And it is a state suspension and like on-demand computation. That's what we understood. So now let me go for one more function. Say I have a typical function like this. My function, say first I have something. Okay. It's a typical function I have initially printing the function. So within that also, I just wrote yield statements, that thing, but I'm making a call. So if I make a call, it's an ordinary function. All the executions will execute, that's it. But so the moment I place a yield, things will be different. You see, if I assume that in middle, I wrote like return I. Now you see what will happen? The execution will start, but it will pause. Is it pause or like terminated? Terminated. Because return is the last statement to be executed. After that, if you ask also, it will execute and again the same thing. If I ask the again foo, it will execute again from the starting till that place only. But if I do the same example, so instead of a return, if I go with a yield of I, then the things changes. So the moment I make a call, it will create a generator. So I need to take the result into something. So result is equal to foo. So and for this result, I need to ask the values. You know that I can go with a for loop or convert to another data type or using a next. I think using next is best because you can better understand. I told you when you assign a result also nothing will happen. The moment you start asking for the first value, then execution will start and it will go till the first yield. So whenever you make a function call, first it will check whether it is a function or a generator. The very first thing when you make a call, it will check whether this function is a generator or a thing. Means whether there is a yield or not. If there is an yield, it becomes a generator. So the moment you call, it creates a generator. If it didn't notice any yield, then it treats like an ordinary function and it will execute. So it see here, it executed and passed. So till here. So, but like next time when you ask next of result, so result, you can notice that it will resume execution from that position till the next thing. So means like again, if you ask, it will resume the execution till the next execution. So again, if you ask, it will resume the execution till the next. But unfortunately, you didn't write a return in the last. Means if you write also, if it return, you didn't write any space statement. That's why during the stop iteration, you didn't get any message. So this is how things will work. And I told you, so we can apply in a for loop or do anything like that. And also I told that we can use the result dot underscore underscore next also to do the things. So both also works in the same way. In the same fashion. So there are like multiple things we can do with the generators. So whenever you have a large computations to be done, so instead of you doing all of them, you can do like a on-demand computation. Due to that, like so the overall performance would be good. Means like if you are given a logic to generate like 1,000 prime numbers, but in those 1,000 prime numbers, if you are using only 10 among them, so then what is the point, right? So let me take a generator. So a problem. So problem generator for prime numbers. Prime numbers. Let's solve in a prime numbers how to generate. If you are given some numbers and within that numbers you want to generate. First think like an ordinary way. Say get primes. If you are given some limits between, so or like get primes till say number. If you are given a number till that number you want to get all the primes. Then traditionally what you do, so I do like a for number in, so range of, so generally primes will start from 2 onwards, 2 till that number. This is one of the interview question which was asked recently. If the user is asking any number less than 2, so there is nothing, right? You do. So generally you take a primes as a one of the list and you generate. So if number is less than 2, then you say like, return this primes, which is like an empty. But if it is greater, then you generate. So how I generate? So for the given number, I will check for the so for n in, so range of, so from 2 onwards, because any number is divisible, a prime number only when it is not divisible by any other number except 1 and itself. So from 2 till number I go, means it will not consider because number is the last thing. Till that value it will go, and for each other number I will do, means like number percentile, so n is equal to 0. I will check. If anyhow it is happening, so then I will break. So if not, else, in that case, so I ruin else. In for loop, when it will come to the else? When all the for loop was executed and it didn't encounter a break, in that loop it will come to the else. In that case, I do like a primes dot append of whatever number we have. So like that I do, and finally I return the primes. So this is what we have. This is an ordinary function. I didn't do a generator. So in an ordinary function, so if I do like a get prime still, number of, let me give some 20 if I give, and if I ask the results, you can notice that nothing is coming. So unfortunately, so it should come. Oh, number, so correct only, right? Number percentile n. For each of the numbers I am generating, the primes. So I should debug. So where the number is. I think like, so it will generate somewhere the problem is. So means like if so I need to make so there are multiple ways. You can have a breakpoint and do the things. So but like here, so if you want to check like where the problem is, so maybe like I'm doing a hello. You see, this is how I traditionally used to do. Now hello went here, means similarly I do here. It didn't go. So what is the problem? I told here that if number is less than 2, then return, not if greater than 2. So that's what I solved the problem. Now you see, you get all the values. So each time in the process, it is printing also, and I'm removing the number. You see, finally, you got the result. Means problems cannot be a big thing. Mainly, anytime bugs will happen with the conditions only. So you should be aware. So I generated these many numbers. Just imagine how many loops it has gone. It need to check for all the 20 values to get the values. But what if I used only 2 among them? Unnecessarily we are generating. To avoid that, how we can do? Using generators. So, so till say like I wrote like a gen. So for the generator. In generators, you don't create these values. So you need to comment. So whenever you have the values, so you need to return. Means instead of printing it, you return the value. So means like yield that number. The user will take care of getting these values, and you are not supposed to do. So means like finally, so you will not return anything. You will say that return is for what? So no more primes. So no more primes or none or whatever you do. So now you see here, I have changed that scenario. If the value is less than that, then there is no point, right? So yield and empty. In other case, you just pass the values. Now you see, get prime still gen, if I pass, if I execute, it creates a generator. It won't give the value directly. So now if I want to get the values, I need to get to this. So how I need to do? First, so result is equal to this thing. And for that result, I need to ask, so next of the result. Did you see one value was generated? So maybe like for better understanding, I can write here, say prime number colon and here like this. Just I'm executing again and you can see now, you see prime number 2. And again, if I ask, it will execute till the next execution and give the next element. And again, it will give the next element. And again, it will give the next. Again, it will give the next. So like that, it can generate. Now the advantage is that I need not wait. I can generate even crores of values also. I need not be worrying about it. So this is one practical example of generators. So hope you understood. In the same fashion, for any problem like this, you can generate using generators. So one more simple example, let me give. So the more examples you do, so the better you can remember. Another example, it's a very simple example for you to understand. Say if I go for generators like this, I have yield hello, yield world. Only there are two. Then what will happen? So when you make a call, it will not execute. That we know. So, but like we need to assign to some result. Then if I get to the values, I can get like multiple ways. If I just ask what is gen, it will say like it is a generator. But if I want values, either I can use next built-in function or underscore underscore next. In both ways, I am asking. So both the values came. And after that, if you ask, it will throw an error. That we know. And similarly, so one more use case for this is whenever you are working, if you want to get like a countdown or like a proper index number. So whenever a new record is getting entered into a database, you want a unique value. So you have like, so a unique value you can assign to them like that you can have. And they recently they added like in Python 3.7, I guess, they introduced something called as yield from. This is another interesting thing. So means like they found every time what are the common problems users are facing, then addressed it. So whenever if you want to yield values from an iterator, so this is most commonly used. So the advantage I will tell. Say if you want like a number iterator, say like I have one example like this. I am doing a range of n, and from that range I am passing each of the value one at a time. So when you ask for the say, so range of these values, what will I get? And I'm converting to list such that I can get the result. So if I'm trying to get it, so what will I get now? So from this range only one at a time, it is getting the values, right? So they found that the most common problem people are finding is that you have a sequence and you are parsing that sequence. Means like, let's say I have a sequence parser. Means I'm taking a list. From in this list, each of the time it is doing a for loop and giving the value of it one at a time. Either I can apply for loop or like convert to anything. Any way I can get, right? So for us to simply to understand, if let's say I'm converting to tuple, you can see the same values. Means if any time you have a scenario where you have an iterable and you are getting the values from it, in those scenarios they told like, instead of you doing like this, you can do a better strategy. So what is that they told is that instead of you doing a for loop and asking, as you know that it is an iterator, you can do yield from range of n. So if your strategy is exactly like this, you can just do. Now did you see in both cases the answer is same? Similarly, in this case, what you have, you are looping out the list of values and you are getting. So instead of you looping the list and getting yielding, you can do like a yield from, so my list. So then it will do the things automatically. So hope you understood the advantage of going for this yield from. But this yield from is not suitable whenever you are going for a something complex. Means if I go for this edge case, where instead of yielding y, if I am doing like y to the power of 2 or some operation I am doing, I cannot do like this, right? This operation I cannot do from yield from. So yield from can't do this. So yield from can't do this. It means just getting values is fine, but if you want to do some other computations, then yield from cannot work. And one more thing, there is one more thing called as generator pipelines. This is very, very interesting and important. Generator pipelines. So hope you are aware of pipeline. So home pipelines. Pipeline means what? There will be multiple pipes you join, right? You create like a pipeline. So then you will, once you become a data engineer, you call it as a data pipelines, ETL pipelines. So pipeline means think like, one is connected to another, one is connected to other, like that something is happening. Say we have one example. The example is like this, that if you are given a number, so we need to first filter the even numbers and convert, multiply by 3 and convert to string. If you are given like that, so how you do? So maybe like you write one function. So in method 1, so what you do? If let's say you are given a list of values or like some interval of values, then what you will do? In first method, what we do is like first I create like a even filter. So even filter means if I was given some values, so I need to filter that even numbers from it. Means if I was given a list, I will take like number in nums. If number percentile 2 is equal to 0, so even numbers, I need to create one list like even nums, and I need to add this list called as numbers nums dot append of numbers. So finally, after your work, you need to return this even numbers. So this is what your first function. So similarly, you told that I need to multiply by 3. Multiply by 3 means for that also you need to write the same logic. So means like in the same fashion, you create a function. So first printing the print statement, then you for each of the number you iterate and you multiply by 3 and you add to a list. And in the same fashion, you have for each other number if you are given, you need to convert to a string also. So for that, I create one more function. So for a given function, I need to pass, and it will convert each of them to a string in a particular format and give the result. Means for each of these things, if you want to get the result, so how to do? So first we need to pass to even filter. So I will take some numbers and I need to pass to this one. Say like I will take some numbers. Say I'm taking some numbers like so and so. So now what I will do is that first I will pass to the even filters. Even filter result I am taking. Okay. So maybe evens something error. So then I have like multiply by 3. For that I will pass these events. Okay. So maybe like mul3 I will write. And that result I will pass to convert to string. Convert to string. This is another function. For that I pass to the multiple. Hope you understood. And that I will say like a result. And I'm asking. So this is what the pipeline means. So assume that if there is no pipeline, individually things are happening. I will tell you how things are working first. So if I go with like a typical way, so if I ask like, hey, first is like even filters, right? It is just like executing. I am passing the numbers to it and I'm asking the result. And similarly, if I ask like print of f of multiply by 3 of the same numbers if I pass. And similarly, print of f of convert to strings of the same numbers if I pass, and I'm asking. In all three cases, if I ask, did you observe carefully what happened? When I did a even filter, I got all the numbers. From that numbers, I got even numbers. And when I apply multiply by 3, for all the numbers, it is multiplying by 3. But when I'm converting to string, all numbers are converting to string. This is like individual functions. But if you want to create like a pipeline, so pipeline means you do it the other way. So what we do is like, as I told just now, we need to do means pass the numbers to the first one. That result we need to pass to the second one. That result we need to pass to the third one. And now if I ask the result, which is a pipeline. In the process, did you see? So final results you got means did you see that these numbers are even and multiplied by 3 and converted to string? Now the same thing you can do in a single line also. So how I can do in a single line? Instead of assigning to a intermediate values, I can assign. So this is also a pipeline like this. You see, first I pass to the even filter. That result I pass to multiply by 3. That result I pass to convert to string. Now the same pipeline gave the same result, right? Just for you to understand, I wrote like this. But in reality, we do like this. But finally, you understood what? However you write. So first, all the numbers will go to the even function. The result numbers will go to this one. The result numbers will go to this one. Now, in our list, how many values are there? Just 10. What if I have like 1 crore values? So if I pass to all of them, when I will get result? When all of them were processed, only then I get it. No, sir, not like that. What if you have 1 crore values also, but I want immediately? Means whenever something was processed, immediately I want. So for that, I need to go for a second method, which is called as a generator pipeline. So you know pipeline just now, you know generator. What is this generator pipeline means? Very simple. In earlier case, what you do, every time you are looping, within that you are appending to one list and you are returning that list. So every time you are doing the same thing, appending to a list and returning that list. But here in the last thing, what we do is that instead of you returning to a list, how I did earlier, like that you yield the value. You don't do any return. So no list again here. So whatever you comes, you just yield. Whatever you comes, you just yield. Whatever you comes, you just yield. Now for these functions also, I can call directly without a thing. Means even for this also I can ask. Means like I can ask like convert them to list, because by default this even filter, if I pass my numbers, so numbers if I pass, it will give the value like a generator. It won't give the results, right? So then what I can do, even in this scenario also, I can pass to like a list. So if I do like a list, I can understand, right, what is coming. So and similarly, if I the same thing if I pass to a other one, means like multiply by 3. If I pass to multiply by 3, individually that process will execute. Whereas if I pass the same thing, so list of numbers of strings of numbers, I get the 3 things. But if I make like a pipeline, means you understood. This is also a pipeline, this is also a pipeline, right? So just I'm taking this pipeline and I'm doing the same thing here, like a pipeline. So pipeline. So now I am asking, hey, print the result. What is this result? It is a generator, right? The generator is passed to another generator, result is passed to another generator. Now you see, it is not like a single function with a generator, multiple functions with generators. Now observe carefully. If I do a next, Did you see what happened? All the three functions were executed and you got the first value. Hope you understood what I'm trying to say. So in your three functions were executed the moment you made a call. In a traditional way, this doesn't work. Only with generators it works like that. Now, even if you have 1 crore or 10 crore values also, one by one, all the values will be processed. So in each value iteration, when you are asking, one value will be generated. So again, if you ask next of result, so next value will be generated. So means only in the first time only the functions will be called, right? Subsequently, everyone will be near the yields. So it will go to the next loop within the yield only. Again, print statement will not print. So for us to better understand, I gave that. So if I give like a next yield, so it will process the next value. If I do like a next thing, I get it. And similarly for the result, I can do underscore underscore next also. So I can get it. The remaining values, maybe like I want to do a for loop. So remaining, so value in result. If I do means what are the remaining values are there, it will just execute remaining value. You see, all the other values are printing. Means, oh, fortunately or unfortunately, I came to the last thing and you don't have any more. So like that, these generator pipelines will work. This is all the concept of generator pipelines. So hope you understood. So any doubt till now?
No.
Fine. So this is called as the concept of generator pipelining. And the next one is the concept of generator expression. Now you understood the concept of generator. You can tell better than me. So in the same fashion, so there is generator expression. Hope you remember when you are working with comprehensions, I told this concept. So we know that if we can do something in a for loop, so for I in range of say 9, I can print the values if I want. I can print the values I can want. But if you want the values, you take like a list and you do, right? Say like a new list I take, and for I in range of 9, you do what? So instead of printing new list dot append of so that I. So finally, if you ask, hey, what is the value of this new list? You get all the values. So instead of you doing this much struggle, I told that we can do the same thing in a comprehensions also. Means same new list is equal to, in a comprehension, you can do what are the for loop you want within it. And after that, if you have a condition also, you can write. Or if not, what are the value you are doing, you can just add. So this is how we have created a comprehension. So this is called as a list comprehension because the process is called as comprehending and used a list to get the values. And if you ask, you will get the values like a list. In the same fashion, you can also create the comprehensions with the other four also. Means like a set comprehension you can create. If you are storing the braces or with the flower braces and you have like a single value in it, so it is a set comprehension. So set comprehension, if I ask the values, it will give like a set. In the same fashion, we already seen the dictionary comprehension. Means same like the flower braces, but with a column separated values. Something, whatever you give. That is a dictionary comprehension, which also you have seen. But the last thing I told is, if you store the results in a parenthesis, it is not called as a comprehension, but like a generator expression. In fact, we assigned that to a generator expression. And if you ask the type, it will tell the same. If you ask the type of it, it will not tell that I am a comprehension. Means above also they won't tell comprehension. They will say list set so and so, but it will not tell tuple. It will say it is a generator expression. So what is the point of generator expression? I told that. At that time I didn't tell much because, so now I want to tell. If you want to get the values, either you can do for loop or convert to another data type or use a next built-in function on them to get one value at a time. So you can also use, so this one dot underscore underscore next underscore underscore, like that you can get, or like you can apply a for loop also or while loop also for val in so and so. So print of val, if you do, it will get the values. So this is the generator expression. So when you want to use, whenever you have a large data to compute, process, so you can do that. So instead of storing the results entirely, it will do like this. And if you see, compare in terms of the memory. So I have like list comprehension, memory, all these comprehensions, right? So for all these things, if I compare the memory, so for comparing memory, I told there is something called a sys module. Sys dot get size of. Sys dot, so get size of. If I do like a list comprehension, so list comprehension, so print of, I will do like a f string, multiple f strings, such that in one shot I can see all the results. Observe, for the same values I am doing a list comprehension. So I will do a set comprehension, and also we did a dict comprehension. So dict comprehension, I think it's not coming because of this only. Dict comprehension. And finally, we have like a generator expression. So for generator expression also, I will take. So if I show you the results in terms of what they are doing, did you see what happened? List comprehension is taking how much? So set is taking the highest, and generator is next. And like see here, generator expression, how much it is taking? The least of the size is because this. So did you all understand now? So generator expression will not take much memory because that is like a minimum. It will not take more. In the same fashion, there is one more thing called as chaining of these generator expressions. Chaining of the generator expressions. So in which case it works like that means same like the generators. So we have seen generator expressions. Now let me create some generator expressions for this. First, I want to create, say like some integers, maybe like a range of 9. It is not a pure generator expression, right? But still, it's some kind of. So now I want to do a squares of these numbers. So what I'll do for each of the number means for I in range of 9. For each of the number, I want to do the squares. So what I do, I into I to the power of 2. So that is I square, right? So squares I want to do. Then after that, I want to negate it. Negated means for each of the value, I want to negate it. So minus I for I in squares. Now you understood what? So first it will have range of values. For those range of values, okay, instead of doing directly, I will do here integers. For those integers, I pass to a loop or it and get square it. And for those values square, I will do a negate. Means they were related, right? Directly. So now, finally, I'm asking the results. So if I ask like, hey, what is negated? It will say it's a generator expression. You get nothing. But if you ask the values, so number in negated, if I ask to print the number, did you see that it will parse all these values and get it? And of course, we know that like, how it works. To better understand that, so again, we need to regenerate again. If I ask the values, so how to get, um, I need to define again, and I need to ask. If I defined again, and if I ask next of this negated, you see, it will pass through this, through this, through this, means all the chain. So whatever I showed in the previous pipeline, so like that it will go, and it will give one value at a time. So like that it will go and give you. So this is what I mean to do. And if you want the final result, maybe like I can do a negated like this. So you can see every time it will do. So like this, so this is the chaining will work. So based upon these things, you can do some assignments. So my assignments are like this now, that so using the generator concept, display all the prime numbers from 0 through 99 crores. So it's not a difficult, right? 99 crores also you can do. Of course, I created a prime numbers in the top, but it is still a particular value. But here you are got at the same thing. You need to extend it. Now, I was given some list of values. Using that list, you need to take the slice and you need to give the values. Means this is one of the most common thing. In real time, you will use a lot. If you are given a ordinary list, you need to divide to slices. Means each time you need to get a part of it. Means three values at a time. Three values at a time. Generally, when I'm using when a DB connections or sometime, if I have like 1,000 records, if I need to dump to database, I will dump like 50 records at a time. Means 1,000 records were divided to 50 at a time, like chunks. This is a real world problem. So how we can do is like, if you are given a list and if you are given a slice size, means 3 or 4 or so and so, you need to write the logic to get it. So this is a very, very important thing. So in real time. And also you can create a range function, like a custom range. However range is working, in the same fashion, you can do this also. This is a very good examples. I think you will learn something good from here. Next, based upon these things, there is another thing called as coroutines. So till now we have seen the concept of values generations. So there will be one more thing called as consumers, called as coroutines. The name itself is so different. You will learn something very interesting. Coroutines. Generally, routine means what? A routine means like a function. The other name for a function is called as a routine. So what is a coroutine? A function which can help the other functions or kind of new thing. So what is this that you will learn here if I say? So there was a pip. So there is something pip. Pip means Python enhancement proposal, which I told in the starting. For everything, if you want to make, there is a new pip. So like that, they created a new pip for this new enhancement. So this is called as core coroutines via enhanced generators. Means they enhanced the generators to get it. It was created way back in 2005. It's very old, but still they follow with that. So what is that? Till now we have used generators, but generators are like data producers, whereas coroutines are data consumers. So what is this consumption? So these also use yield, but they will use a brace around the yield. Sir, what will happen if you place a brace around? That is the magic. So let's see. So till now we have a generator, right? So we know the concept of a generator and all these things. So if you write like a ordinary print statement and you do a return, it is not a generator. So but like if you write a yield, it is a generator. That you know till now. So the moment I wrote a yield, so whenever I make a function call, instead of executing it, it will help me. One second. Yeah. Instead of executing, it will create a generator object that we are aware. So, but like, what is that you want to tell here? So if I say, instead of printing, if I assign to some value and print the result. So now you see, type is of generator, it is generator object. And if you ask next only, you get the result. This is what we know till now also. But what is a coroutine? A coroutine means, so same like your generator, I write it. So means like no print, ignore that. You have a yield, right? So same like that, I wrote a yield here. I write a yield. But so instead of directly returning, so I will assign this result to something. Value is equal to like this, and I do a yield of the value. Sir, what is this magic? Means it will not be a yield. It is still a generator only. So because if you ask hello, it will not give the values. But if I do like a next of hello, so means we need to assign to something, right? So maybe if I assign to something, I get it. Means like same like this example. I copy and execute. It will be the same. Nothing different. But this one, if you want to modify like a coroutine, if you want to make like a coroutine, the slight difference is here also I need to make a yield. Observe very, very careful. There are two yields here. So here also first I do a yield. That yield result I place to something and that I pass it. Then it becomes a coroutine. So the moment I define like a coroutine, so the logic is same. Coroutine is also a generator, but it enhanced version. What it does, nothing like that. So if I assign to a variable and ask the values, observe carefully, it will tell. Sir, you told coroutine, but it is still saying generator. Yes, there is nothing like coroutine data type. Coroutines are also generators only, but with slight difference. So what is that slight difference? How it can be helpful? I will tell you shortly. At the same time, if I create like this, means I am not assigning any value to it, but the yield result I am assigning to this variable, and that I am again doing. Means first you get the value from yield to a variable, and from that variable again yield that variable. So this is also a coroutine. So these two cases are coroutines, but if you ask the type, they are generators only. Sir, something interesting, something like confusing, right? But fine. If you see, now let me give you one more example. Then you can understand. So another example. If I say here, I wrote like a yield, default string, and yield that value. And this time, two times I'm doing the yield from the same variable. And again, I'm doing yield new string and yield from that variable. So coroutine is also a generator. So whenever you are using a coroutine, the first step is to call the coroutine. Means it's like, whenever you want to play a game. So means you are throwing a ball, but someone should receive it. Means someone should be ready to catch, right? In the same fashion, so whenever you are doing two steps you need to follow. So even in a generator also, whenever you want to make a do, first you make a call, right? So even in a generator also you make a call, but if you ask the type, it will say generator, but you did nothing. The moment you ask for the first value, the execution starts, right? So in the same fashion here also, the moment you ask for the first value, the execution starts. Same like this thing. But this concept is called as priming. So this concept is called as priming. So means same like a generator, you need to do the first time next function. Then it will be primed. Means it will be ready to catch anything. So from then onwards, so till now what happened? You do a next, 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 right? So rather than doing a next, next, and so, you ask for the values. Means you do a c dot send. Till now you are asking the values. Now you are sending the values. So the moment you send the values, it will get the values. So means like, say instead of direct send, let me do like this. C dot send of first, C dot send of two, C dot send of three, like that. I'm passing three values and I get the results. Means whichever the value I'm passing, so I'm getting it. But for the first time, I got a default string because the moment it executes, it will return the first yield, right? The first yield is default string. That's why you got when you did a prime. Subsequently, you are passing two values. You got it. So you did like a first also you got first, second also you got first. Because when you say you passed values, it is taking the previous value only, right? You did it two times. And the third time when you did a third value also, you are getting new string. Because though you have passed some value, you are assigning a default value. And subsequently onwards, if you pass any value, it will do that. Means Now what is the current state? Currently the location is this. So if I do like a c dot send off, say, fourth, if I do fourth, did you see I get the fourth? Because I am at the final line. Now if I do like a not only fourth, I can do anything, maybe like the same 1 2 3 again. I am at the last line, so whatever I pass it will execute. So instead of like first so and so, second so and so, you see now, means like it don't have any more values, yield came down, so there is nothing more values to take. So that's why it stopped there itself. So it stopped there. Yeah. So means like finally it came, there is no more values to pass, so we were done. And in any coroutine, the last step that you need to do is like close it. So closing the coroutine. So for every coroutine, there are 4 stages. The first step is to make a call, same like a generator. Second step is to prime it, same like asking a next value. And from then onwards, you send the values. And it should be ready to receive at the function definition. When you have one value, you cannot receive. But let me do like one more example this time. This time I will do like a infinity. So then I can pass more things, right? So the same example with slight difference I do. Another example with infinite receive. Okay. You see in this case, what happened? I took in a while loop. So while true means every time it will go. So for the very first time, I did a yield one number and I'm asking from further the received value. That's it. So I told the process, when you define, the first step is to make a call and the second step is to do a priming, means ask for the next value. For the first time you are asking a next. After this yield you have a default value which is 1 2 3 4. You get it. And subsequently, so as it comes every time to that position, you will see what will happen. Now we see the first 2 steps are mandatory. I am doing it fine. Then I do the actual value sending. I pass 3 values and each of the time when I am passing values, you observe what will happen. The moment I did a first, did you see? The first is whatever I passed, it is going in place of this number and you are getting received and you are getting the value. And if I pass second or third, it will work. Now I can do any number of times, means there should be yield to get the value. So finally, the moment I pass a yield, I get the value. And I am in a infinite while loop. So anytime it can recursively go and get the things. So instead of these 3 values, maybe I will do a recursion loop to pass like these many number of values. And observe carefully. If I pass 9 or 10 values also it is taking. Earlier we couldn't do because there is no more yield to take the value. So there is an yield means it will take the value from us. And finally all our work is done. So then we can close ourselves. Till now we have seen whenever you did a while loop, there will be a condition to terminate. But in a coroutine, you terminate it using like this. That's done. Coroutine was done. Means after closing, you cannot pass anything again. Means assume that I closed it now. If I do a send of fourth again, then it will throw a stop iteration exception. So coroutine was closed and you cannot pass the values. So like that it will work. And similarly, so what if you want to do with a finite reception? So finite reception. If you want to make a finite reception, in that case, instead of a while loop, I do with a count, some default value, and I do with a range. So by default, it will do 5 times. And if you give a value, it will do this much number of times. And the process is same every time. And observe, in this case, you are not using the I. You can replace with an underscore. So means, and the process is simple. Every time, first step is like making a call. Second step is like making a priming. And the third step is you passing the values. So third step is you passing the values. So here it is a finite number of times. Means it can take only 5 times, right? because 5 times only it can loop. So observe carefully. So 3 times I passed. I got the values. Same like in the previous thing. I do 9 times now. So you see what happened? Here 3 times it has done. 3 plus 2, 5 times it's done. So the moment extra you passed, it should be stop iteration. Means unlike others, last case, it didn't do the n number of times. So, and last point for any coroutine is that, so you need to close it. And subsequently after closing, if you ask, it will say that I cannot do more. So like this. In the same fashion, like how you have done the chaining of a coroutines, in the lines we can do here also chaining of the coroutines. So means like for producing also we had done. In the same fashion for this also we can do. I'm giving a simple example. So for you to understand quickly, um, let me create one producer. So there is one producer. Simply think that if you are giving one sentence and I am passing the next coroutine, you see it will split that sentence and each of the word it will take and pass to the next coroutine. Means next coroutine it will send to the next coroutine, and finally the next coroutine will be closed. And in the same fashion, so I have like one more coroutine. So its job is like filtering the pattern filtering. Means like if you give one pattern, it will filter that. So for suppose I am doing ing. So it will do in a while loop. Whatever the token means the word you passed, it will check whether it is having that pattern. Means ing is there or not in those words. If they have, it will pass to the next coroutine. What are you giving? So this is one coroutine where it will take the strings and it will divide to words and it will pass to the next coroutine. Similarly, this pattern filter will check for this ing, and if that pattern is present, then it will send to the next coroutine. And also you are seeing for the first time that generator exit error. Means when our things were done, so finally we get an exception, right? So that can be handled with generator exit exception. Similarly, I will create like one more coroutine. So its main job is whichever was words which are coming, which were having the ing, that filtered, I want to print them. So that will be taken here and the taken and it will print them. Now I have like 3 coroutines. Now I need to make a pipeline. So pipeline, how you make? Say pipeline can be done in different ways. If I say, so first I'll make a call to the, in a reverse direction I need to go. So first I'll make a call to this print token. Generally, if you make a call to the print token, it is a generator. So I will assign this to something called as pt is equal to that result I will pass to it. And I will ask for the next. You know how the coroutine works? I told coroutine means first we need to make a call, then we need to do the priming. Means ask for the first value. The moment you did a priming, it will be ready to do. So it will started, priming started. The execution cursor is here. Similarly, in the same fashion, we need to go for the other one, pattern filters. So for the pattern filter, it is taking like one coroutine, right? It is taking the pattern filter and like coroutine. So then like I will pass like this. So the filter, what are the text pattern is like ing only I leave. And the next coroutine I need to pass. So what are the first coroutine I created, that I will pass as an input. Now this result also I will assign to something like pattern filter. And here also I need to do a next of this pattern filter. Means coroutine means first we need to make a call and do the priming. Means first time you need to ask for a done. Now these two were done. So we have like the producer and all these things. Now if I pass, I have a sentence. The producer what is doing? Producer taking two things. One is a sentence and the next coroutine. So let me take one sentence. This sentence I need to pass to the producer. So producer is taking like the sentence and the next coroutine. I can ask to take the sentence. So whatever you have, maybe like that sentence I will take. Okay. If you want, I can say like here, like a keyword arguments, sentence equal to so and so, and it is taking the next coroutine. So next coroutine. So for the next coroutine, what I can give is this above PF, whatever you did the PF coroutine that I will pass. So now it's very clear. This producer is taking the sentence and also this next coroutine. If I execute now, you can notice entire sentence it will process, and inch by inch it will process all the things. Means instead of all completing it once, whenever things were done, it will execute it. So that's the beauty of going for a chained coroutines. And in the last stage of this coroutines is about async IO. Async IO means like this is another variant I would say. Anyhow, we will work more on it in the separately when you go with concurrency. But this is another module which was introduced, and it can be helpful for different purposes. This concept is called as asynchronous programming. So whenever like we are working on, there is a module called as async IO. This module will help to work in a non-blocking structure. Though I will tell the concept afterwards, just imagine like what is a blocking and non-blocking structure means. Typically, whatever you're seeing in Python, Java, C++, how it actually happens. If there were three statements, so first statement is like getting data from something, second statement is connecting to database, third statement something else. Assume that each statement is taking 5 seconds. So totally how much time it will take? First 5 seconds. After the statement was executed, it will go to the next step. Next, it will go to the next step. So totally it will take 15 seconds, right? But there is another way called as a non-blocking structure. In non-blocking structure, the same statements can be. So till now what happens? After the first statement is completed, only then a cursor will go to the next line, right? But in non-blocking execution, like Node.js is one language, and similarly we have our async IO. It will just give a hit and it will go next line. Means it will not wait whether it was completed or not. Then if you ask like, sir, if you are defining some variables here and if you are using it, so what will happen? You should take care of writing. So this is a slight different way of writing. But the point is, it will take the max thing. Means it will take the same old time. So how we need to run? So this async IO module we will use. But what you need to understand is this old style of coroutines. This coroutines has inspired to this async IO programming completely. But traditionally, these coroutines are an inspiration for it. How it actually worked is, if you create like one function, it is like an ordinary function. I wrote like a yield from, means it's a generator. So whenever I make a call, you will see that, say like I made a function and I'm making a call to it. So how it works, if you go for the terminal and execute this particular program, Python be so and so. So when I executed, nothing happened because like, it will not call, right? So if you want the values, I can ask, hey, what is this object? Did you see that it is a generator object? In the same fashion, if you want to get the values out of it, I can convert to list or for loop on it. I convert it to a list. What is saying? Hey, cannot yield from a coroutine object on a non-concurrent generator. Means something like, very crazy, right? So what they did is, based upon the existing coroutines, they slightly modified it. What they did is like using like decorators, right? So like that there is some coroutine decorator. So they added this coroutine decorator and they asked to use. But now the error is different. It is saying that no running event loop. Means it's simple. Just imagine like one circle is running. After that circle is running and you are passing everything to that circle. Just imagine a big wheel is running. To that big wheel, everything you will throw, and in that wheel, everything will run. That is the concept of event loop. Means if you want to first create an event loop, there is something called as asyncio.run. So what are the functions you want to call these coroutines? So we need to pass to that. Means I have my old style coroutine. I make a call. You make the call within this one. Means asyncio.run will create that event loop, and whatever you run within that will execute. So if I execute, will it run? You see something started, right? What is saying? Hey, coroutine is deprecated. So since so and so, use directly async diff. Means this is the first definition of how to create a coroutine and the usage. Now the latest definition of doing the same is you need not do like this. You can do things in a better way. What they say is like first we need to first define using async. Async is a keyword in Python. You need to define. Same like the old style, whatever you have, I will pull the same code. But instead of a decorator, we need to define a async before it. The moment you define a async before it, it changes the entire scenario. And you need not use this await wait recursive. Whenever you are doing like this, instead of doing like that, you need to do a different strategy. So there is like async sleep, like that. There is something called as await. So in consolidation, in Python from 3.7 onwards, they created these two keywords called as async and await. Using that, I can do. Means within that, if you want to wait for something, I can do a await for this call. Now, if I want to run, so the same logic, first I need to create the event loop, and within that event loop only, I need to make a call. Now I need to make a call to my main function. Now you see what will happen. So this is one event loop, this is another event loop. Mean within this event loop, we can call any number of functions. So if you want. So that's it about it. But we can learn more about this async IO programming in the later.